Okay, so I'm sorry because the video is cut off. So we are going to continue with the third question. Okay, so we have two forces in two direction. Okay, and since as I told you before, force is vector, so direction plays an important role. Okay, so one is on the left and one is to the right. So we must minus the forces. So the total force is 18 minus 2, we get 16 Newton. Okay, and by using F equals to ma, we can calculate the acceleration. F is 16, m is 10, so A is 16 divided by 10. A is 1.6 meter per second per second. Okay, so this is question C. So now let's look at question D. Okay, look carefully at the diagram for question D. Okay, we have 1, 2, 3 forces. Okay, uh, two force, two forces are to the left and one force to the right. Okay, once again, force is vector. So different direction, we must minus, same direction, we add. So total force for D is 10. Okay, I think we better uh, write uh, 5 first, easier. Okay, 5 Newton to the left and plus another 5 Newton. Okay, and then we minus 10 Newton to the opposite side. Okay, so 5 plus 5 minus 10. So 10 minus 10, 0 Newton. Okay, so using F equals to MA, 0, 12 kg A, 0, ms negative 2. So for the object D, the acceleration is 0. So there are two situations that could happen to the object at D. One is it is at rest because the acceleration is 0, or it can move, but with constant velocity because the acceleration is 0. Okay, so let's continue to the for question B, I got it wrong, calculated wrong. Okay, so number 2, a man pushes a trolley with 5 kg box on a smooth surface. When the question states smooth surface, it is knowledge. It is stating that friction is negligible. Okay, if you use a force of 30 Newton to move the trolley, what is the magnitude of direction and direction of the acceleration of the trolley? Okay, so this question, the answer is here, and the question is more or less the same as the question number 1. Okay, so let's look here. An object of mass 2 kg is pulled on the floor by a force of 5 Newton and having a constant velocity. A. What is the friction force between the object and the floor? So now we have an object, 2 kg, being pulled by a force of 5 Newton. Okay, so let's look at A, the frictional force. Let's look at the question, having constant velocity. When an object is moving with constant velocity, so the acceleration is 0. Okay, so if the acceleration is 0, F equals to ma, 5 plus friction equals to 2 kg times 0. So friction is, this is 0, sorry. Yeah, this is 0. Okay, so 2 times 0 is 0. 5, we move it here, negative 5. Okay, so the friction is 5 and the negative symbol is the direction. So the friction is to the opposite direction, 5 Newton. Okay, so B, calculate the acceleration of the object if the object is pulled by 17 Newton force. So now for B, the eraser won't come up, never mind. Okay, for B, the 2 kg object is being pulled by 17 Newton. So 5 Newton is no longer. Okay, this is a new situation. However, we know that the friction on the surface of the floor is 5 Newton. It is fixed because it is being pulled on the same floor. Okay, so since at the beginning we've calculated the friction as 5 Newton, negative, opposite direction. So if the box is being pulled by 17 Newton force, the friction is still 5 Newton. Okay, so the total force here is 17 minus 5 equals to 12 Newton. So by using F equals to ma, 12 Newton times 2, A, so A is 6 meter per second per second. Okay. Okay, so let's go to question 4. A bus of mass 2000 kg travels with a uniform velocity of 40 meter per second for a distance of 250 meter before it comes to rest. Calculate average deceleration of the bus. Okay, so we have an object or a bus with 2000 kg. Okay, and then the bus move at a distance of 2500 meter. Okay, and it stopped, but initially it moved with 40 meter per second. Okay, so now we need to calculate the deceleration of the bus. Okay, so when we draw the situation, we can see clearly. We have the value of the mass, we have the distance, we know the final velocity, we know the initial velocity, and we are to calculate the acceleration. So what is the formula that consists of S, consists of V, consists of U and A? So we can use V equals to U square plus 2AS. So V is 0, U square 40 square plus 2 times A and S 2500. Okay, so okay, 40 square 1600. Okay, negative equals to 2,500 times 2, 5,000 divided by 5,000. Okay, so A is 3.2 meter per second negative. Okay, so this is the acceleration of the object. Okay, so B, the average force applied by the brakes to bring the bus to a standstill. We've known the acceleration, we know the velocity, so we need to calculate the force. So now by using F equals to ma, F we don't know, m is 2000 and a is 3.2 negative. So 2000 times 2000 times 3.2. So the force is negative 6,400 Newton. Okay, negative sign show the direction of the force, which is the opposite of the motion. So let's say if the object move to the right, the force is being exerted on the opposite direction, okay, which is to the left. Okay, so 0.32. How did I get the 3.2? I think my calculation is correct. So 5,000 divided by 1600. Yeah, 3.2. Okay. Okay, and then from there we can get the force. Okay. So this is an experiment to investigate the relationship between acceleration and force if the mass is constant. Okay, so for this experiment, we put a trolley onto the runway, okay, and it is connected to a ticker tape passing through a ticker timer. Okay, what different between the experiment that we've done before? The trolley is being tied to a mass. Okay, so the mass is constant. The mass is changed. Okay, how by changing the mass here we can change the force? Okay, as you can see, the mass is pulling the string connected to the trolley. Okay, so if we add more mass, we get more weight. Weight is a type of force. Okay, and the weight is pulling downward. So by increasing the mass, we are increasing the force exerted onto the trolley. So we can investigate the relationship between acceleration and force. Okay. So the hypothesis is the higher the force, the higher the acceleration. So manipulated variable is here lah, the force. Okay, we change the force. So force is manipulated variable. Okay, the responding variable is, since here is relationship between acceleration and force, so responding variable is the force. Is the acceleration. And the constant velocity stated here, mass is constant. Okay, so apparatus as shown in the diagram, all the apparatus. We must write all the apparatus. Ticker tape, ticker timer, trolley, AC power system, inelastic string, weight, okay, and a pulley. Okay, Here, the runway is a friction compensated, as we have done before. Friction compensated trolley is a friction compensated runway is a runway that make the trolley move with constant velocity. Okay, so this is the procedure. Here first we place the trolley onto the runway, and then we uh, tie a weight at the end of an elastic string, and that passes through a pulley. Okay, and this is what we will get for the result. Okay, force and the acceleration, referring to the ticker tape. Okay, so after we've done the experiment, we draw the graph, and the relationship should be force is directly proportional to acceleration. We should get a straight line graph. Here is force, here is acceleration. Okay. Okay, as for this one, is relationship between acceleration and mass. So previously is the experiment acceleration against force. So force is we change the weight here. So for this experiment, for the relationship between acceleration and mass, the weight that is connected to the inelastic string is fixed. What we add is the mass on the trolley. We put something on the trolley. We put weight on the trolley. The more weight we put, the more mass the trolley will be. Or we can add another trolley. We can put one trolley, two trolley, three trolley, and so on. Okay. So the higher the mass, the lower the acceleration. Okay, so we know the manipulated variable is the mass, responding variable is the acceleration, and the constant variable is the force. Okay, so the apparatus is the same: friction compensated runway, ticker timer, AC power supply, okay, wooden block, trolley, smooth pulley, inelastic string. Okay, what is not here is the weight. Okay, we put at the end of the inelastic string. So same goes with the previous experiment. The method is more or less the same. It's just that the mass on top of the trolley is changed. Okay, so after we draw the graph, we will see that the mass is inversely proportional to acceleration. Okay, so now let's look at the question. A cyclist cycles his bicycle with a force of 120 Newton. If the total mass of the bicycle and cyclist is 80 kg, the acceleration is, okay, force exerted by the cyclist is 120 Newton. And don't forget, look at the diagram. We have 20 Newton force in opposite direction. So this is the friction. So the total force is 120 Newton minus 20 Newton friction. So the total force is 100. So by using F equals to MA, force 100, M is 80, so A is 100 divided by 80, 1.25. So the answer is C. Okay, so let's look at the second one. Which of the following system will produce maximum acceleration? So to get maximum acceleration, the total force should be the biggest. Oh, I forgot to tell you, total force is also known as resultant force. Total force, okay, the exact uh, concept is resultant force. Okay, so A, the total force is 10 minus 80, 20 Newton. B, total force, we have two forces, same direction, so also 20 Newton. And C, we have two forces, same direction, also 20 Newton. Okay, D, we have one force to the right, 50 Newton, and the other force to the left is 28. Okay, so 52 minus 28, so this is 24 Newton. So the answer is D. Okay. Number 3, the diagram show a Formula One racing car. Why does the car design engineer use light composite material for making the body of the car, although its engine is powerful? Okay, so we've discussed the experiment relationship between mass and acceleration. So the smaller the mass, the bigger the acceleration. So the answer is A. Number 4. Diagram show a car with a mass of 1000 kg moving with an acceleration of 2 meter per second per second. There is a frictional force of 90 Newton acting on the car. What is the force exerted by the engine of the car? Okay, so we want to know the force exerted by the engine of the car. Okay, so we know that the frictional force is 90 Newton, 900 Newton. So to get the total force or resultant force, F resultant, we must first minus the force exerted by the car, which is F, let's say is F1, okay, minus the friction, 900. So now we don't know F1, we don't know Fr, but from the information given, we can calculate the Fr. Okay, so because of the Fr, because of the resultant force, the car with mass 100 kg accelerate with 2 meter per second. So Fr is 1000 times 2. So the resultant force is 2000 Newton. Okay, so we substitute this value, 2000 Newton equals to F1, the force exerted by the car, minus 900. So F1 is 2000 minus 900. So the answer should be A. Oh, plus, sorry. Okay, so because this is a negative sign, when we shift to the left, it should be plus. Okay, so the answer is 2900. So please don't make my mistake. Okay, number 5. F1, F2, and F3 are forces with the same magnitude acting on a wooden block. Which diagram show the maximum resultant force acting on the wooden block? Okay, so which force produce the biggest total force? Okay, resultant force. So we have 1, 2, 3 forces same direction. So 3F. Okay, we have two forces to the left and to the right, and one force to the left. So 2 minus 1 is 1F. C, two force to the left and one force to the right. Okay, so 2F minus 1F is 1F. Two force to the right, one force to the left is 2 minus 1 is 1F. So the answer is A. Okay, number 6. Diagram 5 shows a toy car of mass 4 kg. The car is pushed forward by a force of 10 Newton. The frictional force between the toy car and the floor is 2 Newton. What is the acceleration of the toy car? Okay, we have a toy car of 4 kg. The car is pushed forward by a force of 10 Newton. The frictional force is 2 Newton. So before we can calculate the acceleration, we must first calculate the resultant force. So the resultant force is the pushing force 10 Newton minus the friction, which is 2 Newton. So the resultant force is 8 Newton. And by using the resultant force, we use F equals to ma. F is 8, A is 4, sorry, M is 4, so A is 2 meter per second per second. Okay, so let's look at question 4. Diagram 4.1 shows a 50 kg box pushed by a man with force of 300 Newton. The box moves with constant velocity. Okay, number 1, what is the meaning of force? So once again, don't use F equals to ma to define force. Don't. F equals to ma is not the definition of force. Okay, so force is defined by pushing or pulling. B. What is the frictional force acting on the box? So the keyword here is constant velocity. So because the object is moving with constant velocity, so there is no acceleration. When there is no acceleration, acceleration is zero, so resultant force is also zero. In order to get resultant force zero, there have to be two forces opposite direction with the same value. So we have the pushing force is 300 Newton, so the friction must have the same value. Okay, so 300 Newton. Number 3, sketch a displacement time graph motion of the box. Okay, so please look carefully. The graph is displacement time graph and the motion is constant velocity. So what is the graph? It's a directly proportional graph. Okay, because once again, this is a displacement against time graph. And from the gradient of the graph, S divided by T, S divided by T, we get V. So gradient is the velocity. Okay, so since the velocity is constant, we must only get one velocity. So it is a straight line graph. Okay, so we stop here, and later please do the exercise I give. Maybe I'll give the exercise in the Google Classroom.